Hello, let's continue our Sudoku adventure with Coincidence by Matt Tressel. So we have normal 6x6 Sudoku rolls, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have this blue loop in the grid. It's a line, but it's also a loop. The way this works is it's a region sum line. So what we need to do is we need to look at everywhere it crosses a box boundary, basically one of these bold boundaries. That's going to split it into segments. So the two green cells are a single segment, and then these purple cells are a segment. These yellow cells are a segment, etc. as we move along. Every segment on the line, if you were to sum up the digits on that segment, it would be the same sum. So whatever these two green cells add up to, it's the same sum as these four purples and these three yellows, and the rest of the line as well as it splits up. All right, that's the region sum line. In addition to that, we do have some V's in the grid. V is the Roman numeral for 5. Those two digits add to 5. So these add to 5, these add to 5, these add to 5. Unless we say otherwise, not all of them are given. So just because these add to 5, it doesn't mean these don't add to 5. These could also add to 5. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so V's, I'm just going to immediately put 1, 2, 3, 4 into them, because adding to 5 is either 1 plus 4 or 2 plus 3. Now, something we do know is, however this is adding to 5, this adds to 5 in the other way, right? Because if this is like 1, 4, then this cell now can't be 1 or 4, making it only 2, 3. So the only way we're adding to 5 is with another 2, 3. Or, the opposite would happen if this was 2, 3. So we know they're different. I don't think I need to color quite yet to see if that's interesting, but the other thing I'm noting is the longest segment on this line is 4 and the shortest segment is 2. So 2 cells at maximum add to 11. If we were 5 plus 6, we'd be 11. 4 cells at minimum, 1, 2, 3, 4, add to 10. However, there's a problem with 1, 2, 3, 4 because look, we have too many 1, 2, 3, 4s in this box. We can't get the 5 and the 6 in this box now. So the minimum we can actually do is 1, 2, 3, 5, which is 11. So if the minimum is 11 and the maximum is 11, guess what? Our sum is 11. So we already have these. These are valid marks now. This is the 4, and then this has to be the 6 for the box, giving us the 5 and 6 here. All right, the 4 goes with a 1 to add to 5. And just like my example, that makes this a 2, 3. This can't be 1. Okay, so we know 4 cells adding to 11. 1, 2, 3, 5 is the only way to do it. One way you can think about that, in case, case checking sucks, right? So any way you can avoid case checking with sums is helpful. So a nice way to think about this is 1, 2, 3, 4 is the absolute minimum digits, and those add to 10. So if I want to get from a sum of 10 to a sum of 11, I need to add 1. But I can't add another digit in, so I need to add 1 to one of these digits. But the only digit I can add 1 to without causing a digit to repeat is the 4. Like if I add 1 to the 1, I'm now 2, 2, 3, 4, which isn't allowed. If I add 1 to the 2, I'm now 1, 3, 3, 4, right? So the only digit I can add 1 to is the 4, making it the only way to add to 11, which is 1, 2, 3, 5. We are going to need a 6 in this column, so that ends up here. And this is the 4 that's missing from our 4 cells. So if that's not 4, then this isn't 1. We're going to need a 6, actually exactly here. So now we know these two add to 5. These add to 5 and these add to 5, meaning the 5 ends up here. And these are just the other way to add to 5 that isn't this way to add to 5. These have to be a 5, 6, because they need to add to 11. Now these 3. Okay, 3 digits adding to 11 is pretty open, but we don't have a 1. So if we think about it, we can do our minimum thing again. 2, 3, 4 would be our minimum, because we can't use a 1. And actually, I'm going to ignore this 2, 3 for a second, because actually this 2, 3 tells us how it's going to resolve anyway. But 2, 3, 4 is 9, right? So I need to add 2 to our minimum. And so I could add 2 to the 4 to make 2, 3, 6. But the problem with that is now I have too many 2, 3, 6s. I don't have space for the 4 and 5. So we're not going to do 2, 3, 6. So we're not just adding 2 to the 4. So we need to add 1 to 2 of the digits. The only way I'm going to do that is to add 1 to the 4 and then add 1 to the 3. So I end up with 2, 4, 5, which is indeed 11. And that's the only way we're going to add to 11 here. And so these can't be 4. And so this is the 4. And now that's 3 and 2, because the 2, 5 pair, giving us the 5 and 2. This is our 6 for the box, giving us 5 and 6 here. This is our 1. Anything else obvious here? This is going to be the 3 and the 4. All right. 1, 2, 3 over here. That can't be the 2. Let's clean this up a little bit. Red marks bother me. All right. This is a way to add to 5. Let's see. This is only 1, 3, or 4. So if these add to 5, we can either do we can do a 1 plus 4, but this can't be 4. We could do 3 plus 2, or we could do 4 plus 1, but this can't be 1. The only way is the 2 plus 3, making this 1 and 4, making this 1. 3, that doesn't quite finish yet. We get the 3 in this box, though. Let's just plonk our digits. I think we're done. We just have to plonk. That's 2, that's 5, that's 1. That's our 5 and 2, that's our 3. These two digits are 2 and 4, and we're done. All right, nice puzzle, Matt. I enjoyed that. I think there was some neat logic. I liked all the min-maxing, and then how these V's were very well placed to kind of force a particular sum to happen, which otherwise wouldn't be forced. So that was also neat. So yeah, let me know how you did. If you enjoyed this, then why not leave a like, subscribe, and a kind comment below.